Okay, hello grade 12s. Welcome back. It's been a day now. I hope I gave you enough time to be able to go over all the material that I've posted before. Now, since we've done everything in terms of differential calculus from first principles, we've even done an application in terms of the simple basic y is equals to ax to the power n. Now, we know that not all functions of x are going to be this simple. Sometimes you can get a function like y equals to 4x cubed plus, say, 2x squared minus 3x plus 2. Now, before we get into this, I just want you to take note of something that's very important. In fact, it's two things. Now, when you're given something like y equals to a constant number, let's say a, okay? Or better, let's use an example. Let's say 2. Now, remember that whenever you have a constant, there is but a silent x that is there. Okay, but it's to the power 0. That's why you see you've got a 3 here, a 2 here, and a silent 1 there, and then there's a x to the power 0. So that x to the power 0 exists. So what that means is that when you're now finding your dy dx, remember what we do with the first step. You bring the 0 down, which multiplies the 2x to the power 0 minus 1. Now, regardless of what the 0 minus 1 is going to give us, the issue is we're multiplying by 0 already. So whenever you differentiate a constant number, like in this case it was y is equals to 2, you will always get a 0. What does this mean in your geometry? Because if I was to draw anything that is of this type of a graph, it'll always be a horizontal line. And what is the gradient of a horizontal line? Is that the gradient is always going to be 0, regardless of where it is, whether it's negative, whether it's positive, whether it's actually y equals to 0. As long as you have the gradient of a y equals to a constant number, your derivative, your first derivative is always going to be equals to 0. Okay? Now that's the first one. Now the second thing that I want you to take note of is when you have y equals to a constant x. An example being like y equals to 2x. We've actually experienced this before in the other videos, but I'll still bring it out here. So as long as your power is 1, all right? As long as your power is 1, our dy dx is always going to be first procedure, bring the 1 down, 2x to the power 1 minus 1. This will then give us the 1, which will always be there, times 2x to the power 0. Now we know that this will always give us a 1. So the answer is going to be equals to 2. So for this case, if you notice, the answer is always going to be equals to the coefficient of x. So in other words, the simplified results of those two is that if your y is equals to a constant, and if your y is equals to a constant x, then your results are such that dy dx is always going to be equals to 0 here. And then for this one, dy dx is always going to be equals to the a, whether the a is negative or positive. This set of results will save you a lot of time whenever you're differentiating. And then I'll explain how this come into this question that we're formulated later on in the next video. Okay, thank you, and join me in the next video.